For ages, people have wondered what was around before the Big Bang. It's a question that messes with our heads and pushes the limits of what we know. Imagine standing at the very beginning, staring into nothing, and wondering what was there before our universe popped into existence with the Big Bang. There was a moment that started time, space, and everything else. But was there anything before that moment? Was it just empty? Or was there something we can't even imagine? As we dig into this, science takes us on a wild ride through theories that make us rethink everything. Brian Cox, a physicist who knows a lot about the universe, thinks something really weird might have been there before the Big Bang. He wants us to rethink what we believe about reality, time, and space. We're going to check out the science, the ideas, and the strange mysteries that might tell us what happened before everything else. We'll talk about cosmic inflation, quantum stuff, dark energy, and even the multiverse. What we find might surprise you and maybe even change how you see our place in the huge cosmos. Get ready for a journey into a place beyond imagination, where the unknown scares researchers. Let's look at what might have existed before the Big Bang, and why these ideas mess with what we thought was true. To understand what could have been there before the Big Bang, we need to understand what the Big Bang actually was. Scientists say it was the moment when the universe was super hot and dense and then quickly grew, creating all the stuff, energy, and forces we know. When we look at the stars at night, we see proof of this hot start, with galaxies moving away from a central point. But why did it happen? And was there anything before this hot, dense start? According to cosmic inflation, there was a before, and it wasn't empty. Cosmic inflation says that before the Big Bang, the universe was cold, empty, and huge, like a giant nothing. But this nothing wasn't really empty. It had a ton of energy that made space grow super fast. This process, called inflation, happened so fast that it set the stage for everything that followed. In a flash, space grew at crazy speeds until it slowed down, and the energy changed into matter, particles, and the forces we know as the Big Bang. But what was this energy? Why did it suddenly make the universe inflate? And why did it stop? Scientists think that this cosmic inflation created different areas of the universe, each with its own Big Bang. Each area represents a universe, including ours. This idea is called the inflationary multiverse, and it says that there could be a bunch of Big Bangs and universes. Our universe is just one of them. This huge idea messes with our understanding of the universe and makes us wonder what else is out there. The idea of nothingness before the Big Bang is still just a theory, at least for now. Even if you took away all the energy, particles, and light from the universe, it still wouldn't be totally empty. Our universe has dark matter, dark energy, quantum fields, and other forces that create something even in its emptiest form. The universe would still make new kinds of energy. This confuses scientists and suggests that true nothingness might not be possible in our universe. When we dig deeper, we see that space itself has stuff that stops it from being completely nothing. Imagine trying to make a place with absolutely nothing in it. No particles, no light, no energy. But quantum fields and basic constants would still be there. That means that this nothingness would still have stuff. One thing is zero-point energy, the lowest energy level of quantum fields. In this state, particles can appear and disappear quickly, leaving a ghost of activity even in empty space. This messes with our idea of a true void and shows that even before the Big Bang, there was something that scientists are just starting to understand. If inflation made our universe, then it could keep going. Brian Cox pictures a scary, big inflationary multiverse where universes are always being created and growing. Imagine each Big Bang sparking a new universe, while inflation keeps going somewhere else, making more universes. This could go on forever. This idea of infinite universes leads to a cool thought about a fractal universe, where every new universe can make its own Big Bang. Each universe is its own world, not affected by the others, because of the fast growth of space. This idea is exciting, and worrying, for scientists because it suggests an eternal multiverse with no real beginning or end. What if our universe is just a tiny part of a huge cosmic thing that's always growing and creating? Our understanding of nothingness gets even more complicated when we talk about quantum field theory. According to this theory, the universe isn't just a bunch of stuff floating in space. It's a web of energy fields that fill the cosmos and work together to make everything we see. Even when fields are at their lowest energy level, called the vacuum state, they are still active. Particles can appear and disappear within these fields, borrowing energy quickly before giving it back. This creates virtual particles, temporary things that pop up and then vanish, leaving a faint trace. The idea of virtual particles messes with the idea of a true void. Imagine an empty universe where all stuff, light, and energy have been taken away. Would you have complete nothingness? According to quantum field theory, no. Even in a vacuum, fields would stay active, sometimes making particles. This constant activity in nothingness suggests that the universe doesn't follow our rules of emptiness. The fields and forces exist, filling the cosmos with energy that stops total nothingness. This makes us ask a question. If fields create particles and particles make matter, could the universe have come from this nothingness filled with quantum fields, dark energy, and this weird force that's making our universe grow faster? Could dark energy have existed before the Big Bang? Some scientists think that the dark energy we see now might be left over from an energy field that was around before our universe was born. Dark energy's properties hint at a hidden force that could have been present before the Big Bang in some form. Some theories say that dark energy in a stronger form could have powered the inflationary phase, allowing fast growth. The presence of dark energy means that even if our universe had no matter or light, this force would still be stretching the fabric of space. This leads to a scary idea. If dark energy existed before the Big Bang, it might have shaped the conditions that led to our universe. Could dark energy be the quiet force behind cosmic inflation, or even the start of our universe? As we look at this idea, we face the chance that dark energy might not only affect the creation of our universe but also hold the key to understanding the multiverse. Another theory that suggests the Big Bang isn't the real beginning is cyclic cosmology. This is the idea that the universe goes through cycles of birth, death, and rebirth. In this idea, the Big Bang isn't a one-time thing but a part of a cosmic rhythm, where universes grow, shrink, and then grow again in new cycles. This theory says that our universe could have been born from the leftovers of a previous one. The process of shrinking and growing in a cycle means that there was never a true beginning, but a series of universes appearing, changing, and renewing themselves, forever. Cyclic cosmology raises big questions about time, suggesting that time. Big Bang may forever remain one of the greatest mysteries of science. But the pursuit of an answer pushes the boundaries of what we know and forces us to ask deeper questions about reality itself. Whether the universe emerged from a quantum field, sprang out of a prior collapsing cosmos, or was one of many in an endless multiverse, each theory brings us closer to understanding our origins, and perhaps, our future. Some scientists even suggest that the concept of before the Big Bang might not make sense at all. Since time itself began with the Big Bang, asking what came before could be like asking what's north of the North Pole. In this view, the Big Bang wasn't just a beginning, it was the origin of time and space themselves, and anything before is outside our ability to measure or imagine. Yet the human drive to understand keeps us exploring. New tools, like the James Webb Space Telescope and future gravitational wave detectors, might uncover faint signals from the very edges of time. These clues, whether in ancient light, quantum fluctuations, or the shape of spacetime itself, could someday reveal hints about what lies beyond our cosmic horizon. In the end, the mystery of what existed before the Big Bang isn't just about physics, it's about identity, perspective, and wonder. It challenges us to look beyond the visible, to imagine the unimaginable, and to realize that our universe might be just one note in an infinite cosmic symphony. And perhaps, as we keep reaching into the unknown, we'll not only learn where we came from, but also discover new truths about who we are. The Big Bang, one of science's biggest mysteries. The Big Bang is still one of science's biggest mysteries. The search for answers will probably go on for years, as new theories and discoveries emerge. Could the universe have always been around? Did it come from a quantum event, a cosmic accident, or something even weirder? Or is the true before beyond what we can understand, where time and space don't even matter? As we keep searching, we are certain the quest for answers will reshape how we think about existence for years to come. For ages, folks have been scratching their heads, wondering, what was around before the Big Bang? It's a question that really messes with how we see the universe, pushing the limits of what we think we know. Imagine standing at the very beginning of everything, looking out into nothing, and asking, what was here before? The Big Bang is supposed to be when time, space, and everything started. But before that, was it just nothing? Or something even stranger than we can imagine? Scientists are looking further back than ever, diving into theories that stretch our understanding. Brian Cox, a physicist known for his work on space, believes something truly bizarre might have been going on. He urges us to rethink everything we know about reality, time, and space. In this exploration, we're diving into the science, the speculation, and the head-scratching mysteries that might tell us what happened before everything began. Check out ideas like cosmic inflation, quantum fluctuations, dark energy, and even the possibility of multiple universes. The answers might shock you. To understand what might have come before the Big Bang, we first have to grasp what the Big Bang actually was. Scientists say it was a moment when the universe was unimaginably hot and densely packed, then bam! It exploded outward, creating all the matter, energy, and forces we see today. Look up at the night sky, and you'll see galaxies zooming away from each other, leftovers from that giant explosion. Cosmic inflation. Cosmic inflation proposes that before the Big Bang, the universe was cold and empty, stretched out like a giant void. But even this empty space held immense energy, causing space itself to expand at a staggering rate. This rapid expansion slowed down, and the energy transformed into matter, particles, and forces, leading to what we call the Big Bang. Why did it stop? Some scientists think this inflation created multiple bubbles, each with its own Big Bang. Picture a vast cosmic fabric, dotted with bubbles popping into existence. Each bubble could be a universe like ours. So, maybe there are endless Big Bangs and infinite universes. Ours could be just one of many. This idea challenges everything we think we know. The nature of nothing. Even if you stripped away all energy and matter, it still wouldn't be truly empty. There's dark matter, dark energy, quantum fields, and other invisible forces. Even if we removed all of that, space might still generate new energy forms. This boggles scientists' minds. It suggests that true nothingness might not be possible. Space itself has rules, properties, and characteristics that prevent it from being a total void. Imagine trying to create a place with absolutely nothing in it. Quantum fields would still be there. One example, zero-point energy, the lowest possible energy state in a quantum field. Even in empty space, particles can pop in and out of existence for brief moments, leaving a trace. So, even nothing has something. Eternal inflation and fractal universes. One wild idea is eternal inflation. If inflation created our universe, maybe it never really stopped. Brian Cox talks about a scenario where new universes are constantly being created. Each Big Bang sparks a new universe, while inflation keeps spawning more. This could go on forever. The fractal universe theory suggests that every new universe could lead to more Big Bangs. Quantum field theory. Quantum field theory says the universe isn't just objects floating in space, it's built from energy fields that span everything. Even when these fields are at their lowest energy, they are still active. Particles can appear and disappear, borrowing energy for a split second. These virtual particles are temporary, but they exist. Even in a perfect vacuum, these fields remain active, creating fleeting particles. Could our universe have come from this so-called nothingness filled with quantum fields? Dark energy and the pre-Big Bang. Dark energy, the mysterious force causing our universe to expand faster and faster, might have existed even before the Big Bang. It could have powered inflation itself. If dark energy existed before the Big Bang, it might have created the conditions necessary for our universe to form. Could it be the true driver of cosmic inflation, or even the real source of our universe? Could dark energy unlock the secrets of the multiverse? Cyclic cosmology. Another idea, cyclic cosmology. The universe may go through endless cycles of birth, collapse, and rebirth. The Big Bang might not be a one-time event, it could be part of a cosmic rhythm. Our universe might have formed from the remains of a previous one. In this view, there was never a true beginning, just a continuous cycle of change, transformation, and renewal. Gravitational waves and echoes from the past. Gravitational waves, ripples in space caused by massive cosmic events, could also hold clues. Primordial waves may offer insights into the early universe. But what if some waves existed before the Big Bang? Some theorists suggest gravitational waves could come from a pre-Big Bang era, a time before our known universe existed. The unending quest. What existed before the Big Bang? It's a question that will drive scientific exploration for decades. As new ideas and discoveries emerge, our understanding of the cosmos will continue to evolve. Could the universe have always been here? Did it arise from a quantum event, a cosmic accident, or something stranger? As we journey deeper into the universe, this quest will shape our understanding of existence for generations to come. The edge of understanding. The deeper we look into the question of what came before the Big Bang, the more we realize how little we truly understand about time, space, and reality itself. In everyday life, we think of time as a straight line, with a beginning, middle, and end. But in the realm of theoretical physics, time might not work like that. Some theories suggest that time itself may have emerged with the Big Bang. If that's true, then asking what came before the Big Bang is like asking what's north of the North Pole. It may simply not exist in the way we imagine. String theory and extra dimensions. String theory is another attempt to explain the origins of everything. It proposes that the fundamental building blocks of the universe aren't particles, but tiny vibrating strings of energy. These strings may exist in more than 3 spatial dimensions, possibly 10 or 11. In this model, our entire universe could be a brane, short for membrane, floating in a higher dimensional space. Some versions of string theory suggest that 2 such branes could collide, triggering a Big Bang. If true, then our universe's birth was the result of cosmic events in a much larger, hidden reality. The holographic universe. One of the strangest and most fascinating ideas is the holographic principle. This theory suggests that everything we see, matter, energy, even space itself, might be a projection from a 2-dimensional surface far away. If the universe is holographic, then our concept of before and after, inside and outside, could all be illusions. Some physicists even believe that time could be emergent, not fundamental. That means time might not be a core ingredient of the universe at all, but something that arises from deeper, hidden laws we don't yet fully grasp. Simulations and information theory. What if the universe isn't even physical in the way we think? Some scientists and philosophers speculate that the universe might be a kind of simulation, a vast computation running on an unknown substrate. In this view, the beginning could be the moment the simulation was switched on. This theory raises philosophical questions as much as scientific ones. If we're part of a simulation, who or what created it, and why? The field of information theory also plays a growing role in cosmology. Some researchers believe that information, not matter or energy, is the most basic building block of the universe. This leads to a profound idea, that even before the Big Bang, information may have existed in some form. Spiritual and philosophical reflections. While science searches for physical mechanisms, many people turn to philosophy and spirituality for meaning. Different cultures have long held creation stories, many of which resonate strangely with modern theories: cyclical time, eternal recurrence, the emergence of order from chaos. Could the answers lie at the intersection of physics and philosophy? As science explores the limits of measurement and logic, we may need new tools, both intellectual and imaginative, to comprehend the origins of existence. The future of the search. What comes next? Telescopes like the James Webb Space Telescope are already looking deeper into space, and further back in time, than ever before. New instruments may detect faint echoes from the birth of the universe, or even signs of what came before. Quantum computing, artificial intelligence, and advances in theoretical math might open doors to understanding that are simply beyond us today. One thing is clear: the question of what happened before the Big Bang is not just a scientific puzzle. It's a reflection of human curiosity, the eternal drive to ask, where did we come from? And why is there something rather than nothing? As we keep searching, the universe might reveal secrets more surprising and beautiful than we can yet imagine.